Okay, today we're going to explore what the Earth would be like if the sun were cooler. So let me begin by talking about the temperatures of stars. Stars with different amounts of matter have different surface temperatures. The more matter a star has, the hotter it is. And the range in temperatures for stars, about the coolest stars, about 5,000 degrees Kelvin. Room temperature is about 300 degrees Kelvin. And about the hottest stars are about 45,000 degrees Kelvin. And our sun is about 6,000 degrees Kelvin on the surface. And that is, we on Earth are in just the right place for that temperature to provide the Earth with liquid water on the surface. And that's the number one criterion for a habitable planet, is that its surface has to be able to have liquid water on it. And how does a star create energy? Well, very briefly, the matter, the mass that is the star, which is primarily made up of hydrogen and helium, has gravity, and that mass is pulling itself in on itself, squishing the star, all stars, pulling in as hard as it can, until it turns out that at the very center, when the temperature gets hot enough, hydrogen atoms stick together. We call that thermonuclear fusion. And they give off energy from the center of stars, from the center of the sun. And it takes thousands of years for that energy to get out, going through the gases inside the star. But eventually it gets to the surface, and that's why the sun shines. So we see light because energy was created deep inside the sun and continues to be created that way. So we have our sun, which is just right for us at this distance from the sun. But what if the sun had less mass and therefore was cooler? Well, it turns out that we, because the sun is cooler, we would have to be closer to it than we are today. And we would have to be roughly about the distance, or even a little closer, than Mercury is to our sun. So the sun, we would be much closer to it. It would look bigger, but it would not be as hot. Which raises an interesting question. The sun with less mass would be red hot. And it turns out that any object that is red hot is the coolest of all objects that give off light. A burning match is often yellow. It's hotter than red. When you blow it out and just watch it cool down, it's red when it's coolest. So something that's red hot is the coolest of hot objects. And that's what we would be facing with a cooler sun. We would have to be closer to it to stay warm. Because out where we are, that distance from a colder sun would be too cold out here. The surface would be ice. Life wouldn't evolve. So with a colder sun, we would be closer to it to stay warm. But that, it turns out, would raise tremendous tides on the surface of the Earth. And the tides that are created on the surface, as we talked about yesterday, the higher the tides, the more the Earth has to give up energy. And this time not to the moon, but to the sun. The sun would create really high tides, and as the Earth is spinning, that water, here's the Earth spinning, here's the sun, that water tries to get back in line with the sun. But as the water tries to get back in line with the sun, with the Earth spinning this way, the water tries to go that way. There's friction between the water and the surface of the Earth, and that is what is slowing the Earth down today in real life, and also if it was much closer to the sun. But because of the super high tides, if we were closer to the sun, the Earth, the Earth would be slowing even faster. And by today, about 4.5 billion years after the Earth formed, the Earth here would be orbiting the cooler sun, rotating not once every 24 hours, but once a year. So the same side would always face the sun in that case. And if you lived on this side, on the sun side, sun's up 24/7 all the time. And all the water on this side would evaporate, become clouds. And some of that water, just because of the motion and the heat and everything else, some of that water in the air would go over to the nighttime side. The other side is night all the time. And because it's night all the time, the water coming over to the other side would turn to snow, fall down, and the nighttime side of the Earth would build up snow, and there would be nothing to melt that snow, so the snow would stay there forever. And the only place where you could have life on that world, desert on this side, ice on this side, is right on the boundary between them. And you would have a ring of liquid water with the sun over here, the cooler sun over here, and life would exist only in this ring, which we don't know how big it would be, but maybe no more than 1,000 miles across, and that would be the place where you would find life.